Okay, so today we're given the problem of the roller coaster. So we'll go through it. The height h of meters of the roller coaster is given by h equals -1 over 80d cubed plus 3 over 8d squared, where d is a horizontal distance 0 in meters. Estimate the gradient of the curve, describing the path of the roller coaster, accurate to 2 decimal places at the point where d is a 10 meters, b 15 meters, c 20 meters, d 0 meters. Okay, so the first thing we need to do is highlight the assumptions in the question. So the first thing we're going to highlight is the equation, which is this. And where d is the horizontal distance from 0 in meters. Estimate the gradient of the curve, describing the path of the roller coaster accurate to 2 decimal places at the point where d is. Okay, so the first thing we have to do is write down the equation, which is f of h is equal to -1 over 80 d cubed plus 3 over 8d squared. Now when a question asks for the gradient of the curve, which means the first derivative or the instantaneous rate of change. So the first thing we need to do is to find the formula. And the formula for doing this is f dash h is equal to n of f of x to the n to the power minus 1. And that's our formula we're going to use today. Okay, so we want to find the first derivative of each of these terms. So what we do is f of dash h is equal to 3, bring that down, so it's -3 over 80 d squared, take 1 from the power, plus bring 2 down, so it's going to be 3/4, and then take 1 from the power, which is going to be d. Okay, so that's the equation we're going to use today, so make sure we highlight that, make it clear. Okay, so the first thing we need to do is find the gradient of the curve where d equals 10 meters, so d equals 10 meters. It's simple as plugging 10 meters into our derivative. Just estimate the gradient. So easy substitution, 3 over 80 times 10 squared plus 3 over 4, 10. We'll plug these all in our calculator, we can get -3.75 plus 7.5, and that's equal to 3.75 meters. So we can see that the curve is actually increasing. I'll explain a bit later on. Okay, so question B, where d is equal to 15 meters. Same thing again, plug it into our equation. -3 over 80 times 15 squared plus 3 over 4 times 15. Find the same thing again. Plug this all in our calculator, we get -8.44 plus 11.25, and we get a final figure of 2.81 meters, the gradient. So it is increasing, they're both increasing, you can tell here with a tangent line. Okay, C. We'll do it again, as simple as d equals to 20 meters. Again, same thing, substitution. 3 over 80 times 20 squared plus 3 over 4 times 20. Plug all this in our calculator, we get -15 plus 15 is equal to, is actually in fact 0. Okay, so at this point, the students should be able to determine that the slope of the gradient is actually 0. You see by here the curve here. So which means that there's in fact a turning point, or the height is actually changing direction from a positive to a negative direction, as you can see here, it's going down. D, same thing again. D is equal to 0 meters. Plug it, same thing again, -3 over 80 times 0 plus 3 over 4 times 0. We're going to get the 0 meters, which means there is no gradient at that particular point, which means that the height is just changing direction. So from increasing value, steep all the way up, and then we hit a point where the height is actually coming down, so the roller coaster is actually going down. Okay, that's as simple as that, and there's the answer.